We're now ready to do section 12.3, simplifying polynomials. So we're going to figure out a way to take these polynomials, kind of get all the like terms together, simplify them down. A couple of vocabulary words: monomial, polynomial. Stick those in your notes. Make sure you figure out what those, look those up if you don't know them, or find them as we go along here. All right, let's take a look at some of this stuff, and this is kind of some review, but way back, well, not too far back, but back in chapter 10, we added like terms. So for instance, we said, hey, we could take terms like negative 5d and 2d and put them together, and we can do it using the distributive property, because we can say, well, we could factor a 2 out, or a d out rather. So we can say negative 5 plus 2, all that times d, and then negative 5 plus 2 is negative 3. Put my d back, and I've got it like that. I like to think of it in terms of some kind of objects. D for donuts or something. We have negative 5 donuts and 2 donuts, and obviously you can't have negative donuts. But I mean, it kind of gets you in that frame of mind that you can think that way, in such a way that you understand that those terms go together, and they don't go together with other things like the numbers, like number 7, because there's no donuts, with the number 7 or 4 or whatever, you don't have that. Okay. All right, so let's take a look. First of all, each of these little terms is known as a monomial. So the 5a, that's a monomial. The 4, the 3b, the 7c, all of those are monomials. Altogether, this whole thing is considered a polynomial. In other words, poly meaning many. It has many variables. That's simply all they're trying to do there. Now, what we want to be able to do is simplify these polynomials. And in the past, we have simplified problems like this. We said, oh, come on. All right, my screen doesn't want to work. What are you doing? Try a different color. Close ink. Try again. There we go. Okay. So sometimes we've done these before, where you added those, and you say, oh, these would go together with those. X's go together with X's, and these go together with these, and we'd get it all simplified. Well, we can do that with more than one variable too. So in other words, over here, we did this problem: 3x plus 4 plus 2x minus 8, and I said, well, let's put these x's together and we get a 5x, and let's put the numbers together, 4 plus a negative 8, and we get negative 4. This is an x here. And now let's do it with different variables, not just the number, like we always did it with a variable x and a number. And now we're going to say, what if we did it with multiple variables, like d's and n's? Well, okay, here's how I like to think of this problem. Take each term, if I kind of break this up, take each of those and get all those ones that have the same letter together. In other words, d's and d's. So I'm going to take that, and I'm just going to take every part of what I just circled there. And notice that I include the positive or negative sign in my box that I've got. So I'm going to take negative 5d, and I'm going to take the plus 4d. Well, negative 5d and 4d would end up with negative 1d, or just negative d. And then the other ones is n's, so I'm going to take my n's, and I've got a 2n, and I've got a negative 3n. 2n minus 3n is going to be negative n. So I've got a negative d and a negative n, and there's my final answer. So negative d minus n. Now, that is not exactly the way that they do it. They do it a little bit differently, but pretty close to the same thing. And really the main difference that they do is they rewrite the negative signs as adding a negative number, which is the same thing. Definition of subtraction is you add a negative number. Okay, so those are the things that we're doing there. We're combining like terms and trying to get those together. Not too bad, not too terribly new yet. Okay, now we could also, instead of just having d's and x's and so on, get this here. Okay, we can also have terms like x squared, you know, like that, x's, x squareds, and those types of terms, which those can be in here as well. And these are examples of other terms. Hang on, close you, I don't want you. Okay, I want to kind of, all right. So it talks about this where, you know, if we have 2x squared, you know, that's a monomial because it's the product of 2 and x. And, you know, I can simplify that. So x terms, x squared terms, they're all different. And they're going to show you two ways. I'm going to probably do method 2 mostly when I explain it. I'll go through what they do, but method 2, you know, seems whatever. We'll show them both, and you guys can decide which way you like better. But what I'm going to do once again is I just like to say, hey, just take all these terms and just kind of box them in with their sign, and what do we get? Okay, and then I can say, in fact, let's redo this. All right, so I'm going to take the ones that have x squared terms, and I'm going to put a red box around those, and the other one I'm going to put a green box around it. Okay, and now I'm going to add my like terms together. So I'm going to take the 2x squared minus x squared. Now think of x squared as just being a thing. It's, you know, a donut. So if I have 2 donuts minus 1 donut, what do I get? I get 1. So I'd get 1 x squared. Or I don't need to write the 1, so I just say x squared. And then there's no other term with this one, so it's just going to be x squared plus 4. Okay? So that's actually method 2. Now, let me explain to you what they're doing in method 1 so you can kind of take a look at it. They're using models, and they're saying that the blue big squares, those are x squared terms, and there's 2 of those, 2 blue ones. And then the negative x squared is the one big red one, and then the numbers are just little yellow squares. And so they're rearranging them down here. We've rearranged them, and then they've matched up. A blue and a red together kind of cancel each other out, so that gets canceled out. I'm left with x squared plus 4. I'm not a big fan of doing this. I mean, it's good to understand it, so if it doesn't make sense, that's okay. We just don't have the tiles, I guess, to kind of play around with that, so I don't really have a way for you to do it other than to look at it in the book when they do it. But let's take a look at the next one, and we've got this term here. X squared minus 1 minus x plus 3 plus 2x. All right, now we've got multiple terms in here. So look, remember, x squared, are there any other x squared terms in here? X is not an x squared, so no. So we have that one. Then let's look at x's. Okay, I've got this term here, and I've got this term here. And then I have some numbers, these right here. So, you know, they've got their pretty colors, I've got my pretty colors. Now, let's put these numbers and colors together. So the blue, my x squared, there's only one, so I'm going to start with that. And usually when we write, we start with the biggest power, so we're going to start with x squared. All right, so then I've got to combine these terms. So negative x plus 2x. So negative donut plus 2 donuts would give me 1 donut plus x. And now I'm going to combine these two terms. Negative 1 plus 3. Negative 1 plus 3 equals positive 2. So plus 2. So here's my final answer. X squared plus x plus 2. You need to look at the terms. You need to decide which terms are similar and get all of those together along with the sign that goes along with them. It is very, very important that you do that, especially when you're subtracting. Obviously, the positive signs, you know, they're in there, but you know, when you do the negative ones, if we don't have the sign in there, then we're going to mess those up. All right, that they don't give you sample problems to do here, so I want you to do a few of these here for me. And what I would like you to do on, well, it's page 572, okay, would you do, let's do these. I just think this gets to be a little bit hard. So do 4 through 8. 4, 5, 6, 7, 8. Do those in your notes. I will want to see those. I will give you the answers here in a second, but I want to see you do the work. Okay, if I look at this, these terms can go together. So I'm going to say 4c plus 11d. Whoops, I'm not very good, all right. These terms go together. 4c and c makes 5c. These terms go together. 5d and 6d makes 11d. So 5c and 11 plus 11d. Okay. Over here, if we look at this one, no other x term, no other number, no other y term. Can't be simplified. So we simply write simplest form. And going on to this one now, g's can go together. 9g and 3g makes 12g. That'd be a pretty fast phone. And minus 9h, I don't see any other h's in here, so minus 9h plus 1. If you didn't get it, 3g, 4g, yeah, never mind. Okay, if you didn't get it, it's just beyond. All right, looking at the next one here, x's are different than x squared, so we cannot put those together. So we're going to get x squared plus, we can add these two together, 4x and 2x, plus 6x. And then in this last one, this term and this term are the same. Let's do some color coding here. This term is different. I don't see any other ones that just have x's, and then I see some numbers. So this term and this term. And I should have really included this the way I'm doing it. Okay. So I have a negative x squared plus x squared. Well, that equals 0. So I can just drop that term completely, get rid of it. So let's do the next one. Would be x, 3x, and 5 minus 1 would be, whoops, not equals, there. 5 minus 1 would be plus, give me a 4, so 3x plus 4 would be my final answer. If you do the pictures, you can see these guys cancel each other out. Okay, we get rid of those. This guy cancels one of those, and I'm left with 3x's plus 4 numbers. All right, now I think you're ready to begin.